Hello, and welcome to Machine Learning using SUSE CaaS Platform. My name is Merrick Counts, and I'm a senior engineer on the SUSE CaaS Platform team. And it's really exciting to get to bring you this presentation today. So the SUSE CaaS Platform team has worked very hard to bring you a simple, secure, and easy installation of Kubernetes. And now we are looking to bring you machine learning on top of this cluster. So the topics we're going to cover today are the common problems with machine learning and machine learning pipelines, what problems Kubernetes inherently solves for machine learning, and then kind of how CASP is bringing this all together and what we're looking to bring to you to solve these problems for you. So let's start with the common struggles of machine learning. The very first one, and this is something that has plagued not only machine learning, but just about every aspect of software engineering, is reproducible building and deployment, and more specifically, reproducible training of your machine learning models. So having it come to the same outcome how many times you run it. Just having a reproducible training environment. And this is really important when you're bringing a public machine learning API where people are going to be able to hit this and depend on your machine learning model to work correctly. The next thing that is really important is maintaining these pipelines. So training a model is just the very first step, and not even really the first step. When you're talking about machine learning, there is so much more than just training the model. And sometimes we get focused on training the model, but there is the backing data and how your model accesses this when it's training. It is serving. How do you serve this as an API to somebody? How does somebody use and consume this? How do you collaborate? How do your data scientists collaborate on this? There is so much to the machine learning pipeline other than the actual training. And there's not a whole lot of good solutions out there. The very next thing is scaling. Scaling has, again, these aren't necessarily unique to the machine learning. These are just issues that also are struggles with machine learning. And how do you scale your model? How do you bring it at scale? And how do you scale it in a clean way that's easy to maintain? And then the very last thing that we're going to cover today is collaboration. How do you have large teams that collaborate on a single tool and collaborate on these models to bring the best models possible? So let's look at how Kubernetes and the SUSE CaaS platform can help. So Kubernetes inherently is designed as a scheduler of containers. And schedulers are good at scaling things. So if things are built and designed in a way to leverage containers, these reproducible environments, then it can easily scale out your application on demand due to that. So Kubernetes kind of inherently provides scaling. Maintaining and building and training the models, these are also things that Kubernetes can generally handle very well because you're looking at reproducible environments, and that is what a container brings. And this is what Kubernetes schedules. So Kubernetes out of the box kind of handles some of these aspects for you. But straight Kubernetes doesn't really tie them all together. It provides you the building blocks, but there are still those gaps. So what is the SUSE CaaS platform doing to tie in these gaps? So first, Kubernetes in itself is a very large application from etcd to the API server. It is a very large set of applications that run on your nodes. So the CaaS platform first goes to managing all of that for you. So you want to run your machine learning workloads. You don't really want to worry about all the machines and managing all the infrastructure behind that. You want something to handle that for you, and that's what the CaaS platform does. It handles the Kubernetes cluster behind the scenes for you. And so this is what really the CaaS platform brings to the table. A quick, easy, and secure installation of Kubernetes on one of the best Linux distributions out there. It brings easy updates for security and new features, because Kubernetes, not only does Kubernetes have its own security patches, but the OSs underneath them also. So you have several layers of security patches that get handled for you automatically. Not only this, but you get the knowledgeable support from a team whose whole goal is to be up to date on the best practices for Kubernetes clusters. So we spend time making sure that we are up to date on those and helping develop those for the future. All right. So we've got that the SUSE CaaS platform helps with a lot of Kubernetes stuff, and that Kubernetes has the building blocks for helping with your machine learning workflows. Now let's see what the next step to tying all of that together. Here at SUSE, we have started to get involved with some upstream open source projects. One specifically is called Kubeflow. And what Kubeflow does is it leverages Kubernetes and all of the things that Kubernetes brings to the table and ties them all together in one single package that runs in your Kubernetes cluster that gives you an end-to-end solution for your machine learning workflows, from data analyzation to training the models to running the pipelines and deploying the machine learning model servers. So what have we done? We have started to support and developed a set of manifest files that are specifically designed to run on the open source Cryo container runtime, as well as the Cilium network plugin. So we're starting to work on those, and those are available as of right now. You can go get them. You can test them out in a demo cluster. We are also looking to help support the latest versions of Kubernetes and expanding the support of ML frameworks that are supported in Kubernetes and in Kubeflow. We as SUSE, open source is in our bones, and we are very excited to help the open source community empowering machine learning on Linux. And so with that being said, I'd like to show you Kubeflow on a CaaS cluster. So I have to apologize. This node is running on a separate continent, so it's kind of a little slow and unresponsive, but it's very far away from me. And so while it is a little bit slow, please bear that in mind. I want to show you first here that we have we can run kubectl. We see that our Kubernetes version is 1.17.4. This is the latest supported as of right now with the CASP command line tool. And it was very easy to set up and install with the CASP tool, and now is being automatically kept up to date with the latest patches, security patches. So this is it's a very small cluster. If it's a production cluster, you should never run with just a single control plane. but this is for demonstration purposes only. And now we can go ahead and check on our Kubeflow deployment. Kubeflow is that thing that ties all the Kubernetes components together for us. So this is our Kubeflow deployment, and there's a lot of stuff, and we're not going to dig into all of it, but I'm going to pull out some of the things that you need here. But you have stateful sets, replica sets, your deployments, your services, and your pods. So just a few things that I'm going to pull out is you have a UI that you can look at, and we'll actually go over and look at the UI in a little bit more detail. Then you have your Hatib hyperparameter tuning, you have your metadata servers, you have your ML pipelines, and you have your Selden server and your TensorFlow workloads. So this is the general layout of your Kubeflow deployment. And you can see that it's leveraging the operators, the Kubernetes operators for your machine learning workloads and those deployments. So this is the deployment, and it's running on a CaaS cluster. So let's go ahead and jump over to the UI. So here is the UI for Kubeflow, and this is the central dashboard with recent notebooks and activity. This is actually set up using LDAP, so we actually have authentication enabled and working so that you can use it in a large team environment where you want to restrict access to certain things, as well as harness the ability to manage resources. So what team gets how many resources can all be done through Kubernetes and Kubeflow by empowering you to use the namespaces to restrict that so that your teams don't accidentally step on each other's toes. So the very first thing that we have here in Kubeflow is pipelines. I do apologize for the slowness. This is, again, going across the ocean. So our pipelines here are the things that are going to allow you to create, and here's some example pipelines. These are pipelines that give you these reproducible experiments. And you can see each one of these. The really cool thing about these pipelines is each one of these is its own container. So if you look here, this is a container with its own input and its own outputs. And this is really awesome because it's harnessing the power of containers to give you a reproducible training. And not only that, is it gives you details at each step, because each one of these, and when you see artifacts over here, you'll notice that each one of these containers produces its own output, and that's the input for the next step. So the input from, or the output from this container is the input to this container if it required input. And so these artifacts are built each time a pipeline is run, and you can schedule the pipelines to run nightly or when there's changes or whatnot, and you get to build up these artifacts. And so you get better insight into your pipelines, how they were running, why they were running, and what decisions they made. And you get this really nice UI, and then you can switch over and look at the source of what that pipeline is. These are the experiments. We haven't run any experiments, but your experiments will run your pipelines. You can create different sets of experiments with different parameters for those pipelines. So you could run the same pipeline with different parameters for testing or to tune it to a different style. And then you can see your artifacts that were produced. Now, the next thing is notebook servers. And this is one of those things where I said collaborations was an issue. What Kubeflow does here is it provides you a way to create notebook servers and share these and restrict access. So you can restrict them via the namespaces or whatnot. And it provides you a way to share your Kubeflow, your Jupyter notebooks as a server and limit the resources and whatnot to them and share them and collaborate as a team. And so that's what this does and how it works. And you can just click here, create a new server. When you're creating a new server, you can create it from a bunch of different images. You can even use a custom image if you have a custom image that you want to use. These are just some of the default ones. You can set the resources for your image, and you can even attach GPUs to it so that it has resources to use. The next thing is Hatib. It is a hyperparameter tuning. So this takes things that aren't learned and it tweaks them and will continue to run them and change them to try to get the highest accuracy or whatever your goal is for that and run it that way. And so this allows you to do some automatic things that will give you a higher accuracy at the end of your run automatically. And yeah, so that's hyperparameter tuning, and it's all automatic, and you can enable it in your pipelines. And then you have your artifact store with all of the artifacts based off of your builds. So this is Kubeflow, and we've got it running, and we've got it going on our Kubeflow our CASP install. And we currently have the instructions for how to use this here. And it will also point you to the manifest repo that we're looking to contribute back up to the upstream as soon as we are finished working on them and updating them a little bit to support the base cryo install. And so, yeah, if you'd like to try to install this on your cluster, please feel free to follow those instructions. If you run into any problems, please just feel free to open an issue so that I know, and we'll start looking into it. And I'd love to hear your feedback. Thank you all for joining me. I think that this is a really exciting time for the machine learning in the open source world. And I look forward to getting to experience this and help bring support for machine learning on Kubernetes on SUSE CaaS Platform. Thank you again for joining. I hope that you're as excited as I am, and I hope that you're staying safe out there. Again, I look forward to seeing you online and seeing how we can better provide machine learning to you.